Good morning to all. See this today in this live lecture we shall discuss the examples based on the definite integral, that means the properties on the definite integral. So yesterday we have solved some problems based on the properties. Now here we are here, properties of the definite integral. This is the definition of definite integral. These are the properties of a definite integral. Yesterday we have solved number of problems based on the definite integral, that is the properties of a definite integral. Now we shall discuss the next problem, that is examples on the properties of the definite integral. So we shall move towards this. Next problem, that is a problem, I think problem number 11. Show that integral from 0 to pi by 4 log of 1 plus tan theta into d theta, which is equals to pi by 8 into log of 2. Now you tell me, how many students have done the homework, yesterday's homework? Please raise your hands. Who completed their homeworks, yesterday's homework? So ठीक है, solution, let I is equals to integral from 0 to pi by 4 log of 1 plus tan theta d theta. Now we have to use the property number 4, integral from 0 to a f of x dx, which can be written as integral from 0 to a f of a minus x dx. That means we have to use this property here. सैनात सेवा रे एकट्यानेच केलं का रे, एकानेच केला का problem? So we can write integral from 0 to pi by 4 log of 1 plus tan a minus x, means pi by 4 minus x, x means theta, bracket close, d theta. So integral from 0 to pi by 4 log of 1 plus, now we have to use tan of a plus b. What is the formula for tan a plus tan b? Upon 1 minus tan a into tan b. Okay, if there is a minus, then we can write here minus and plus. So in this case we have to use tan a minus b, means tan a. Very good, म्हणजे सर्वच जवळपास सर्वच मुलांनी केलेलं आहे. tan a minus tan b upon 1 plus tan a into tan b. Is it okay? You know that the value of tan pi by 4, value of tan pi by 4 is 1, so we can write integral from 0 to pi by 4 log of 1 plus 1 minus tan theta divided by 1 plus tan theta. Very good, मायावती माळी, very good. tan pi by 4 ची व्हॅल्यू किती असेल मग? d theta. Again you have to take LCM in the brackets, so integral from 0 to pi by 4 log of 1 plus tan theta minus plus 1 plus tan theta, 1 minus tan theta divided by 1 plus tan theta d theta. So plus tan theta minus tan theta will be get cancelled, so I can write integral from 0 to pi by 4 log of 2 upon 1 plus tan theta. Okay? Do you understand these steps? If you have any doubt, then you can ask me. Now use log of m divided by n, that means the separation formula 0 to pi by 4 log of 2 minus log of 1 plus tan theta d theta. Here we have used the formula log of m by n, which can be written as log m minus log n. Is it okay? Very good. साईनाथ शेवारे correct. इथं division असल्यामुळे subtraction होतं. Very nice. Now you can separate this integral. I is equals to integral from 0 to pi by 4 log 2 into d theta minus integral from 0 to pi by 4. We can separate this integral, that is a log of 1 plus tan theta into d theta. Is it okay? Log of 1 plus tan theta into d theta. So I is equals to integral, log 2 is the constant term. So integral from 0 to pi by 4 d theta minus, see this, integral from 0 to pi by 4 means second integral is the repetition of the main integral, that is considered, this is equation number 1. So integral from 0 to pi by 4 log of 1 plus tan theta d theta we can replace by I. So we can replace here I, and we can write this from 1. Is it okay? From 1. Very good, Sainath. Now we can take on left side, that will be 2I is equals to log of 2 integral from 0 to pi by 4 d theta. So 2I is equals to log 2 d theta च इंटिग्रेशन असतं theta from 0 to pi by 4. So 2I is equals to log 2 into pi by 4 minus 0. So 2I is equals to pi by 4 into log 2. So I is equals to pi by 8 into log 2. So I means what? Actually I means that is integral from 0 to pi by 4 log of 1 plus tan theta d theta is equals to pi by 8 into log 2, and hence proved. Okay, समजलं? Do you understand this problem? If you have any doubt, then you can ask me. So this is a very important problem. Huh? So this is a very important problem. Okay. So you complete this problem. अशा पद्धतीने हे complete problem होतो. अशा पद्धतीने हे solution complete होतं. Okay. Now we shall move towards the second problem. समजलं का रे सर्वांना? साईनाथ शेवारेचं उत्तर देतो. बाकीचे कुठे गेले? मायावती, ऋतुजा देशमुख, उपाळे, ओमकार सुरवशे, योगिता, हमीद, वर्षा, पवन, बेले, स्नेहा शिंदे. काय करतात रे तुम्ही? आन्सर देत नाही, काही नाही, बोलत नाही, काही नाही. हे नंतर लिहून घेत चला, अगोदर आन्सर देत चला. So we shall move towards the second. That is problem number 12. Integral from 0 to pi x into tan x divided by sec x plus tan x dx, which is equals to pi into pi by 2 minus 1. Actually we have to prove that. Okay, now we have to prove this result. Okay, let I is equals to integral from 0 to pi x into tan x divided by sec x plus tan x dx. Now you can use the property number 4. इथं पण राहिले पहा प्रॉपर्टी 4 लिहा इथं बाय प्रॉपर्टी 4. Property number 4. What is that property? That means integral from 0 to a f of x dx, we can write 0 to a f of a minus x dx. That means replacement of a variable in terms of a limit. So by the property 4, we can write I is equals to integral from 0 to pi minus x. In place of x we have to write a minus x. Here a means pi. See this, what is that property? Integral from 0 to a f of x dx, which is equals to integral from 0 to a f of a minus x dx. That means we have to replace this a, x. In place of x we have to write a minus x. So in place of x, a means here pi minus x into tan pi minus x divided by sec of pi minus x plus tan of pi minus x dx. Okay. So I is equals to integral from 0 to pi, this pi minus x as it is, tan pi minus theta. Who can tell me what is the value of tan pi minus theta? Pi minus theta is in second quadrant. Tan pi minus theta. अगर यहाँ पे पाई होता है तो ये ट्रिग्नोमेट्रिक रेशियो एज इट इज रहता है tan थीटा. अगर यहाँ पे पाई बाई 2 होता है तो ट्रिग्नोमेट्रिक रेशियो चेंज होता है. अगर पाई बाई 2 होता है ना, पाई की जगह पे पाई बाई 2 होता है तो वहां पे कॉट थीटा होता है. एंड वी हैव टू गिव द साइन. हियर वी हैव टू गिव साइन प्लस और माइनस विच इज डिपेंड ऑन द क्वाड्रंट. Now pi minus theta means 180 minus theta. It is in second quadrant, and in the second quadrant tan theta is always negative, so we have to write minus tan theta here. So we can write this as a minus tan theta divided by sec theta, sec of pi minus theta means we can write this as a minus sec theta. Again same, sec pi minus theta means minus sec theta यानी कि x. Again pi minus denominator में pi minus tan theta means minus tan x. यहाँ पे x नहीं है, यहाँ पे theta नहीं है, x है dx. So take out a common minus from denominator and cancel this minus with the numerator's minus. So this minus and this minus will be get cancelled. Then remaining term will be, again we can write integral from 0 to pi minus x into tan x divided by sec x plus tan x dx. Now multiply by this minus, integral from 0 to pi into tan x minus x into tan x divided by sec x plus tan x dx. हाँ multiply करा, you can multiply by this. Okay. Now again separate this denominator and write this, separate this integral also, integral from 0 to pi tan x divided by sec x plus tan x dx minus integral from 0 to pi x tan x divided by sec x plus tan x dx. Okay. Now see this, here pi is a constant, then we can take this pi in out of integral, so our integral becomes pi integral from 0 to pi tan x divided by sec x plus tan x dx minus, see this, this is a repeated integral, 0 to pi x tan x divided by sec x plus tan x. So it will be the repeated integral, and we can replace this x tan x divided by sec x plus tan x dx by I. So we can write this in I. Now transfer this I on left side, I plus I, it will be 2I, which is equals to pi integral from 0 to pi tan x divided by sec x plus tan x divided by sec x plus tan x. Now we can convert this into the sine and cos. We can convert this into the sine and cos. So pi into integral from 0 to pi tan x means sin x divided by cos x upon sec x means 1 by cos x plus tan x means sin x divided by cos x dx. So in the denominator we can take LCM cos x, that will be cancels with numerators cos x, then our final answer will be 0 to pi sin x divided by 1 plus sin x dx. So this is 2I. Now we have to use here the property number 6, integral from here 0 to a, a to 2a nahi hai, sorry, integral from 0 to 2a f of x dx, which is equals to 2 times of integral from 0 to a f of x dx, when f of a minus x is equals to sin x. So now here, okay, here suppose this is a second, here we can write sin of a minus x means pi minus x, a means pi, 0 to a, 2a, and 2a means suppose pi. So sin of 2a minus x, pi minus x, now you tell me what is the value of this? It will be sin x. This implies that f of 2a minus x, which is equals to f of x. Then we have to use by property number 6, by property number 6, if we put 2a is equals to pi, then how we can use the property number 6 like this, integral from 0 to 2a, we have to change the limit 0 to a. इथं 2a आहे तर 2a चं काय करा, 2a we can write in terms of a, means we have to write half 2a to a, put lower limit as it is 0, we have to change upper limit a to 2a, 2a to a means we have to write half, okay, and 2 times of integral f of x dx same. फक्त काय चेंज होतो, वी हॅव टू चेंज द लिमिट इन टर्म्स ऑफ हाफ, 0 to 0, 2a to a. So we can write this as, इथं बाय मिस्टेक a झाला होता, here we have written by mistake a, but it is actually 0. So now use that property number 6. By the property number 6, we have to change this limit, lower limit put as it is, upper limit into the half, means we can change pi into its half value. So 2i is equals to 2 times pi I is it is integral from 0 to pi by 2, half काय येतो pi by 2, and f of x dx means sin x divided by 1 plus sin x dx. इज इट ओके? हे समजलं का रे तुम्हाला सर्वांना? काय अडचण आहे का विचारा. ठीक आहे. sin x dx आपण याला काय केलं, हाफ मध्ये बदलला. नाव डिनॉमिनेटरला न्यूमरेटर मध्ये ऍडजस्ट करा. 2 पाय आय इज इट इज इंटिग्रल फ्रॉम 0 टू पाय. प्रॉपर्टी वापरलं, काय अडचण आहे का या प्रॉपर्टीला? तुम्हाला काहीच अडचण नाही आहे. सो इट विल बी, आता डिनॉमिनेटरला न्यूमरेटर मध्ये ऍडजस्ट करू. sin x plus 1, or we can write, we have to adjust denominator in the numerator. In the denominator there is 1 plus sign, numerator having only sign, so adjust plus 1, 1 plus sin x. For this one we have to keep the equivalent values, so we have to write minus 1 divided by 1 plus sin x dx. Now separate this 2i, integral from 0 to pi, integral from 0 to pi. We can separate this denominator, 1 minus 1 upon 1 plus sin x dx. So 2 pi integral from 0 to pi, sorry इथं pi by 2 येतो. पाय बाय 2 आहे ना अप्पर लिमिट, आता बदललेला आहे. सो इट विल बी पाय बाय 2. वन आता सेपरेट करा इंटिग्रल. 1 साठी 1 dx, dx आहे का डी थिटा आहे रे, dx मायनस 2 पाय इंटिग्रल फ्रॉम 0 टू पाय बाय 2, 1 अपॉन 1 plus sin x dx. Is it okay? 1 plus sin x dx. ठीक आहे. आता काय करू मग, इकडे 2i राहिला, अप्पर लिमिट लोअर लिमिट ठेवा. सो 2i विल बी, इथं काय येतं पहा, 2 पाय 1चं इंटिग्रेशन x फ्रॉम 0 टू पाय बाय 2 मायनस 2 पाय इंटू इंटिग्रल फ्रॉम 0 टू पाय बाय 2 1 अपॉन. आता याला प्रॉपर्टी नंबर 4 यूज करू. वी हॅव टू यूज द प्रॉपर्टी नंबर 4 हियर. सो ओके, 1 प्लस sin x dx. So 2i is equals to 2 pi into pi by 2 minus 2 pi. आता याला प्रॉपर्टी वापरू. इंटिग्रल फ्रॉम 0 टू पाय बाय 2, 1 अपॉन 1 प्लस साइन पाय बाय 2 माइनस x dx by property 4. We have to use by property 4. Property 4 वापरला. So 2i is equals to, हाँ चला रे, इथं काय राहतं सांगा बरं स्टुडंट, पाय स्क्वेअर मायनस 2 पाय इंटिग्रल फ्रॉम 0 टू पाय बाय 2 1/1. आता या ठिकाणी cos π/2 मायनस थिटा मीन्स प्लस cos थिटा cos x dx. हा ठीक आहे, 2 कॅन्सल होऊन जाईल. ठीक आहे, तुमच्या मतानुसार 2 कॅन्सल करा किंवा नंतर कॅन्सल केलं असतं, पण इथं आता होत नाही. सो 2i इज इक्वल्स टू पाय स्क्वेअर मायनस 2 पाय इंटिग्रल फ्रॉम 0 to π/2. 1/1 प्लस कॉस थिटा फॉर्म्युला आहे पहा. 1 प्लस कॉस 2 थिटा असेल तर 2 इंटू cos square theta. So we can write 1 plus cos theta means 2 into cos square theta by 2. Is it okay? So 1 plus cos theta means we can write 1/2 into cos square theta by 2 means x by 2 dx. So these two and these two will be get cancel. 2 कॅन्सल होतं पहा, आणि आता 2 कॅन्सल होत असताना हे 2 आणि हे 2 कॅन्सल होतं. 1/cos स्क्वेअर वी कॅन राईट sec स्क्वेअर. सो 2i इज इक्वल्स टू पाय स्क्वेअर मायनस दिस 2 विल बी गेट कॅन्सल, देन वी विल गेट पाय इंटिग्रल फ्रॉम 0 to पाय. हाँ, व्हेरी गुड. साईनाथ सेवारे, ऐश्वर्या नाडे, सुरवसे, बिराजदार, वैशाली कचरे, माळणकर, योगिता उपाळे, सेक स्क्वेअर एक्स बाय 2 dx that is equals to pi square minus pi. What is the integration of sec square x with respect to x? That means tan x by 2. सांगा रे, sec square x चं इंटिग्रेशन काय येतं? डिवाइड बाय x by 2 चं इंटिग्रेशन 1/2 ओव्हर द लिमिट 0 to π/2. So we can write pi square minus pi, hit 1/2. You can take in the numerator, that is 2 pi, then remaining term is tan x by 2 over the limit 0 to π/2. So pi square minus 2 pi, put the upper limit tan π/2 x in place of x, upper limit π/2 into 1/2, tan π/4 minus tan 0. Tan 0 by 2 means 0. Now you tell me what is the value of tan π/4. So we can write pi square minus 2 pi into tan π/4, tan 45, that is 1 plus 0. So we can write this final answer. Therefore 2i is equals to, the value is pi square minus 2 pi into 1 means 2 pi. Take out a common pi, in a bracket pi minus 2. So you take this I is equals to pi by 2 into pi minus 2. But I means we have considered the initial integral, that is integral from 0 to pi x tan x divided by sec x plus tan x dx. So our answer will be, therefore integral from 0 to pi x tan x divided by sec x plus tan x dx, which will be pi by 2 into pi minus x, and this is the required proof. Is it okay? And hence proved. Do you understand this problem? If you have any doubt, then you can ask me. There is no problem. I will explain each and every term. ठीक आहे ना? तुम्हाला जर काही अडचण आली ना, तुम्ही विचारू शकता. मी तुम्हाला प्रत्येक प्रॉब्लेमची टर्म समजून सांगतो. Now we shall move towards the 13 number problem. Prove that integral from 0 to pi x dx divided by a square minus cos square x dx, which is equals to pi square divided by 2a into root of a square minus 1, and we have given a condition a is greater than 1, because if a will be less than 1, then the answer will be imaginary in term, because if a is less than 1, then this will be the negative. So a must be greater than 1. So we have to prove this result. Integral from 0 to pi x dx divided by a square into cos square x dx is equals to pi square divided by 2a into root of a square minus 1, and it is essential that a must be greater than 1. So let I is equals to integral from 0 to pi x dx divided by a square minus cos square x. So integral from 0 to pi, we can write this by using the property number 6, property number 4, 0 to a. We have to write property number 4, that is a 0 to a. First we have to use this property, then we shall use the 6th property. So we can write by property number 4. So I is equals to integral from 0 to pi, means 0 to a minus x divided by a square minus cos square a minus x dx. Here a means pi. You must write, you don't write here a, pi. Here is pi. Okay, pi minus x, pi minus x. Now what is the value of cos pi minus x here? Cos pi minus x. Who can tell me what is the value of cos pi minus x? It will be minus cos x. But here is a square. So cos square pi minus x means minus cos square x, that will be cos x. So we can write cos of pi, cos square pi minus x means it will be cos x. So I is equals to integral from 0 to pi minus x divided by a square minus cos square x dx. Okay, cos pi minus x is minus cos x, but its square will be plus. So this will be as it is. Okay, so we can write this again. Now separate this integral. आता पाय साठी सेपरेट करा, x साठी सेपरेट करा, then that will be I is equals to integral from 0 to pi divided by a square minus cos square x dx minus integral from 0 to pi, what is that? X divided by a square minus cos square x dx. Is it okay? Now you have to separate this denominator, and again for pi and minus x we have to separate denominator and separate this integral, then we will get this result. So I is equals to, pi is the constant term, so we can take out of integral. So 1 upon a square minus cos square x dx minus, this is the repeated integral, 0 to pi, this is a repeated integral 0 to pi, I will write this as I. Therefore, 2i is equals to pi into integral from 0 to pi 1 upon a square minus cos square x dx. Is it okay? a square minus cos square x dx. समजलं का रे तुम्हाला? Okay. So we can write this as 2i. Now we can substitute by the property number 6 here. आता याला property number 6 वापरू by property 6. आता इथं पहा here, suppose this is a second. Here cos of pi minus x, a means 2a means suppose 2a, pi minus x, which is equals to minus cos x. So we can write this as cos square pi minus x, which is equals to cos x. So we can write f of 2a minus x, which is equals to f of x. Then we can use the property number 6 by property number 6. We can write, 1 minute. We can write the property number 6, 2i is equals to, what is that property? See this. We have to change this limit into the half, 2 times of, keep the same function, we have to write only the limit half. So pi into 2 times of integral from 0 to pi by 2, 1 upon a square minus cos square x dx. Okay, that means we have to change the upper limit into the half and you have to take the integration of 2 times. Okay, बरोबर आहे ना? प्रॉपर्टी नंबर 6 वापरली आपण. So 2i is equals to pi into, so 2 pi into integral from 0 to pi by 2, 1 upon a square minus, we can write cos square x means 1 upon sec square x dx. So we can write this, 2 will be get cancelled, so I is equals to pi into, now these two will be get cancelled easily. We can solve 0 to pi by 2. Cos square means 1 upon sec square. Now take out the LCM. A square sec square x minus 1 divided by sec square x dx. So I is equals to pi into integral from 0 to pi by 2 sec square x divided by a square sec square x minus 1 dx. Is it okay? Now denominator sec square we can transfer on the left new square. See, in this integral, this sec square x, derivative of sec square x is tan. Now derivative of tan is sec square x. That means this sec square x is a derivative of tan. So we have to substitute here tan. But there is no any tan function in the denominator. but we can convert this denominator sec square into tan square for the purpose of suitable substitution. So pi is equals to integral from 0 to pi by 2 sec square x divided by a square in a bracket sec square x means 1 plus tan square x minus 1 dx. Is it okay? So we can put this t here also. So pi is equals to integral from 0 to pi by 2. We can write sec square x, okay, divide by आता काय करता येईल, ठीक आहे राहू द्या, पुट करा इथं, त्यानंतर सॉल्व करू. पुट t is equals to tan x dt is equals to sec square x dx. tan x चा डेरिव्हेटिव्ह sec square आहे. Now this is the definite integral. If we substitute the variable in the definite integral, then the corresponding limits will be changed. That means we have to substitute limits also. That means we have to substitute 0 and pi by 2. When now this is a lower limit is 0 initially for x, so we can write when x is equals to 0, then put in the t tan of x is equals to 0 means t is equals to tan 0, t is equals to 0, so t is equals to 0. We have to calculate the new limits for our given substitution t is equals to tan x. When x is equals to upper limit, that is a pi by 2, put in the t, then t is equals to tan pi by 2, and tan pi by 2 means it will be the infinity. So our integration becomes I is equals to pi integral from 0 to infinity sec square x dx. Now see this, sec square x dx means we can write dt divide by a square as it is 1 plus tan square. Tan square means tan x is t, so t square minus 1. Now again solve this, integral from 0 to infinity dt divided by a square plus a square t square minus 1. So pi integral from 0 to pi, we can write this as a dt, 0 to infinity. So dt divided by a square t square plus this, put this a square t square as it is, we can write a square minus 1. Okay. Now we need the square coefficient must be 1, so we can write pi divided by a square, we can take a common, then integral from 0 to infinity dt divided by t square minus t square plus a square minus 1 divided by a square. So we can write this as a x square plus a square चा फॉर्म मध्ये लिहा. So I is equals to, we can write pi divided by a square integral from 0 to infinity dt divided by t square plus root of a square minus 1 divided by a bracket square. Now we will get the standard form. काय रे स्टँडर्ड फॉर्म सांगा बरं आता, एक्स स्क्वेअर प्लस ए स्क्वेअरचा स्टँडर्ड फॉर्म काय येतो, यू नो दॅट इंटिग्रल ऑफ dx डिवाइड बाय x square plus a square. So we will get 1 by a tan inverse of x by a. So put this pi upon a square into 1 by a root of a square minus 1 divided by a tan inverse of x by a t upon root of a square minus 1 divided by a. Its limit is from 0 to infinity. So we can write pi divided by this a square and this a will be cancelled. A into root of a square minus 1. Now put upper limit tan inverse infinity. Infinity. If we put t is equals to infinity, then tan inverse infinity. आता ब्रॅकेट तुम्हाला स्मॉल करतो म्हणजे थोडं समजायला सोपं जाईल. Minus lower limit means tan inverse 0. T 0 divided by any term means 0. Infinity divided by infinity any term is infinity. So tan inverse infinity ची व्हॅल्यू काय रे सांगा बस स्टुडंट. So we can write pi divided by a into root of a square minus 1 into tan inverse infinity means pi by 2 minus 0. So the final answer will be I is equals to pi square. See this, pi into pi means pi square divided by 2a into root of a square minus 1. And this is the required results. Therefore, I means what? Integral from 0 to pi. What is the actual I? We have initially considered I. 0 to pi x dx divided by a square minus cos square x. X dx divided by a square minus cos square x dx, which is equals to pi square divided by 2a into root of a square minus 1, and this is our required proof. Okay, this is our required proof, so we can write hence proved. Okay, अशा पद्धतीनं हा एकदम छान सुटसुटीत प्रॉब्लेम आपण प्रूव्ह केला. ॲक्च्युअली दिस इज द व्हेरी इंटरेस्टिंग प्रॉब्लेम्स. ऑल दीज प्रॉब्लेम्स आर व्हेरी इंटरेस्टिंग. व्हेरी इंटरेस्टिंग. यू कॅन सॉल्व धिस प्रॉब्लेम. अशा पद्धतीनं हे सर्वच्या सर्व प्रॉब्लेम्स तुम्ही सॉल्व करू शकता. काही अडचण नाही आहे. ओके, तर याच्या बेस्ड काही होमवर्क देतो तुम्हाला. वर्क first, integral from 0 to pi cos square x divided by x sin x divided by 1 plus cos square x dx. हा जो फर्स्ट प्रॉब्लेम आपण पाहिलेला आहे सेम त्याप्रमाणे सॉल्व करायचं. मीन्स आय इज लाईक अ प्रॉब्लेम नंबर विच इज दॅट प्रॉब्लेम नंबर. सपोज दिस इज अ 12. प्रॉब्लेम नंबर, यू कॅन यूज द प्रॉब्लेम नंबर 12. प्रॉब्लेम नंबर 12. Hint, you can use the problem number, solution of a problem number 12. Second, याचा रिझल्ट काय करायचे पहा, पाय स्क्वेअर डिवाइड बाय 4 दाखवायचे. वी हॅव टू प्रूव्ह दॅट. होमवर्क देतो थांबा. दिस इज होमवर्क. प्रूव्ह दॅट ऑल द प्रॉब्लेम्स बेस्ड ऑन द प्रूव्ह दॅट. then integral from 0 to pi, you can use this integral. Break झाला का रे students? Okay, you can use this integral from 0 to pi. ठीक है, ओके, हाँ ठीक है, 0 to pi by 2 cos square x divided by sin x plus cos x dx is equals to 1 by root 2 plus 1. मला वाटतंय काल हे प्रॉब्लेम झालेला आहे, नो प्रॉब्लेम. देन इंटिग्रल फ्रॉम 0 to 1 log of 1 plus x divided by 1 plus x square, which is equals to pi by 8 into log 2. So fourth problem, integral from 0 to pi by 2 sin cube x divided by sin cube x plus cos cube x dx, which is equals to pi by 4. Now you have to solve this problem as like yesterday's problem. This is hint. याला काय करा, याला hint 11 नंबरचा problem solve करा. You have to solve this problem by as like 11 number problem. Okay, no problem. So it will be the next. ठीक है, काही अडचण नाही आहे. इंटिग्रल फ्रॉम okay. Next, fifth problem, integral from 0 to pi by 2 dx divided by 1 plus tan x, which is equals to pi by 4. एवढे प्रॉब्लेम सॉल्व करतात ना सर्वजण? ओके. मायावती माळी, नाडे, योगिता, सैनाथ सेवारे, ऋतुजा, पवन, ओके, वर्षाली, ओमकार, आकांक्षा, ऐश्वर्या. आणि हे माळी, तुला हे सांगतो, रोजची रोज प्रेझेंटी आणि असाइनमेंट्स कोण कोण टाकायला लागले ते पण रेकॉर्ड ठेव, कारण मला वाटतंय ते हाके सध्या नाही आहे, हाकेचा प्रॉब्लेम आहे, त्यामुळे तुला ते कंप्लीट करायचे आहे. ओके, ठीक आहे. नाउ वी शॅल स्टॉप हिअर. नमस्कार.